All right, so this is the second part of 2.6 part 2. And we went over 5a in the last video, so now we're on the part where it's 5b. And remember what we were doing is we were looking to see if there was a horizontal asymptote first, and then we were kind of comparing it by using algebra. So if I look at 5b, I notice that the numerator, the leading power is 2, and the denominator, the leading power is 3. So we have the case here where the numerator is is smaller, is less than the denominator. So let me fix that real quick. So that's the situation that we have right now. So if you remember from the packet, the review packet, that when the numerator's power is less than the denominator, we have a horizontal asymptote, which is y equals 0. So let's go ahead and check this out and see if that works out. So what I'm going to do here is I'm going to divide everything by the highest power in the denominator. So I get 4x squared over x cubed plus 3x over x cubed over 2x cubed over x cubed minus 5 over x cubed. All right, so when I do this, I get 4 over x plus 3 over x squared all over 2 minus 5 over x cubed. And remember, if we said we plugged in infinity, I'm now going to have, and I'll just show you, 4 over infinity plus 3 over infinity squared over 2 minus 5 over infinity. And remember we said when we had a number over a very, very large value, it goes to 0. So 4 over infinity is 0, 3 over infinity squared is 0, and then 2 stays alone, and 5 over infinity is 0. So basically now I have 0 over 2, which is 0. So the limit as x is approaching infinity is 0. And we kind of figured that out by looking at the horizontal asymptote. So let's look at the second one. Same deal. The numerator is less than the denominator. So we know we have a horizontal asymptote where y equals 0. So this is the exact same equation. So I can kind of skip steps. And remember we simplified this as to be 4 over x plus 3 over x squared over 2 minus 5 over x cubed. And when we simplified this down, we got 0 plus 0 over 2 minus 0. So even though we are doing x is approaching negative infinity, remember you have 4 over a negatively large number, it's going to go to 0. So same rules apply, so I get 0 over 2, which is 0. All right, so let's check out 5c. 5c is a little tricky. You got to be careful because of the square roots. So if I change these up, if you remember how to change a square root into a power, the square root of x becomes x to the 1/2 power plus x to the 2/3 power over 2x plus 5. So we have the same issue where if we just look at the powers, we can conclude that we have a horizontal asymptote when y equals 0 because the numerator's power is less than the denominator's power. Okay, but once again, you got to be careful when you're dealing with square roots because when we figure this thing out, we're going to see that sometimes it doesn't always equal the same thing as what the horizontal asymptote is. So let's check this out. So once again, we're going to divide everything by x. So I get x to the 1/2 over x plus x to the 1/3, and that's what I meant to write, not 2/3 there. So let's fix that really quick. It should be x to the 1/3 power over x, 2x over x plus 5 over x, right? Okay, so when I simplify this down, I get x to the negative 1/2 power. And I get plus x to the negative 2/3 power. And then I get 2 plus 5 over x, right? Okay. So remember we're plugging in infinity. So remember x to the negative 1/2 power is 1 over square root of x, right? plus 1, x to the negative 2/3 power is going to be 1 over the cube root. I keep on putting that 2 there. Let me fix that again, guys. Sorry about this. This should be a 1. Actually, no, I was right. I'm sorry. Like, I was actually right that time. Okay, so anyways, we have this situation. And then I'm going to place it over 2 plus 5 over x, right? So this time around, when I plug in infinity, I can take the square root of a positive infinity, no problems. That's going to be 1 over a very large number, which is 0. And then if I take infinity and square it, I get a positive value. So I get 1 over the cube root of infinity. That's fine because that goes to 0 as well. So for the time being now, I have 0 in the numerator. And then I have 2 plus 5 over infinity is 0. So I have 0 over 2, which is 0. So this one's okay. So when the limit as x is approaching infinity, it's going to check out what we thought before, the horizontal asymptote. So we're fine. Let's go ahead and check out the second one. This part 2 of 5c. I'm going to, hopefully you're caught up with me. If not, pause me for a minute because I'm going to erase this stuff just so I have more room. Okay. So if we look at this, we would assume, because this is the same exact equation, that the limit is going to be 0 because the horizontal asymptote is 0, right? So let's go to the point where we simplified it down like we did the last problem. And in the last problem, if I divide everything by x, we got x to the negative 1/2 plus x to the negative 2/3 over 2 plus 5 over x, right? So once again, I'm just going to rewrite this so that we have some clarity. So this is 1 over the square root of x plus 1 over the cube root of x squared all over 2 plus 5 over x, okay? Now I'm ready to go ahead and plug in that negative infinity. So be careful because once again, it is a negative infinity. Okay, so x is approaching negative infinity. All right, so here I got this problem. I got 1 over the square root of negative infinity. Guys, can I take the square root of a negative number? Hopefully you said no. This is not okay because it leads into an imaginary number, right? So if it's an imaginary number, I, this is a problem. So for this particular case, because I had the square root of x and I was plugging in negative infinity, I got an imaginary number. So for this particular case, it is not defined. Okay, so this one is not defined. So what we can say, it does not exist. So DNE. So that one's the weird one. That's why I was telling you to be careful with these, especially when dealing with square roots, okay? Because you can't have a negative underneath the square root. It results in an imaginary number. All right, so let's go ahead and check out the second one. We already did 5D. It says for the next page, and we did not do 5D, so let me zoom this down a little bit. All right, so 5D tells me to find the limit as x is approaching infinity of 3x squared plus x over x minus 1. This is the case when the numerator is greater than the denominator, right? So if I'm looking just at the horizontal asymptote without looking at the limit, I also notice that the numerator plus 1 equals the denominator. When that happens, we know that we have an oblique asymptote. And to find that oblique asymptote, we have to divide the denominator or the numerator by the denominator. So if I use long division, I get x minus 1 goes, geez, I'm hitting all kinds of crazy stuff here, sorry. X minus 1 goes into 3x squared plus x plus 0, right? So I go ahead and divide. 3x squared divided by x will give me 3x. And then 3x times x is 3x squared. 3x times the negative 1 is negative 3x. And then because I have to subtract, I got to change my signs. So I get 4x plus 0. X goes into 4x 4 times. 4 times x is 4x. 4 times negative 1 is negative 4. And then I change my sign. So I'm left with a value of 4. So I write that up as 3x plus 4 over x minus 1. Okay? So the reason why I'm doing this is because I got to use algebra to figure out what the limit is. Right now, I know that I have an oblique asymptote, and the value is y equals 3x plus 4, that line, or close to thereabouts, because remember we have a remainder. So when I do the algebra now, I'm going to take the limit as x approaches infinity of 3x plus 4 over x minus 1. Now, if we plug in infinity, remember I have 4 over infinity minus 1. We know that that goes to 0. Okay, so I'm actually finding the limit as x is approaching infinity of 3x plus 4. So we have 3 times infinity plus 4. That'll give me infinity. So in this case, we get infinity. When you have an oblique asymptote, you're either going to get infinity or negative infinity. Okay, let's look at this other one. The limit as x is approaching infinity of 3x squared plus x minus 1. I already did the work, but this time around we have to plug in negative infinity. So we're looking at 3x plus 4 plus 0, right? So I want the limit as x is approaching negative infinity. So I got 3 times negative infinity plus 4. The answer to that's negative infinity. So when you get that, then the answer to this one is going to be negative infinity. So once again, oblique asymptote, the line is y equals 3x plus 4. Okay, so when you have oblique asymptotes, you know that you're going to have either infinity or negative infinity. All right, so here's a note for improper rational functions. Use long division to rewrite it in proper form in order to find both the end behavior and the oblique asymptote. So that's exactly how we handled 5D. So once again, to handle things with infinity, when you have a rational expression, use the horizontal asymptote rules, but make sure you check it, especially when you get a situation when there is square roots involved. Okay? All right, so let's read this next bit. Definition: infinite limits at infinity. So if I have the limit as x is approaching infinity of some function, it's going to equal infinity or negative infinity, right? And same is true if I take the limit as x is approaching negative infinity. If I plug that in the function, it could equal either infinity or negative infinity. So now we need to read where it says the end behavior of power functions. So the end behavior of power functions, when n is even, so if I have x raised to an even power, and I'm taking as x is approaching infinity, it's going to be infinity. An example of this is 2x to the fourth. If I plug in infinity, remember infinity is to the fourth power, so it stays positive. So the answer is infinity. If I have the limit as x is approaching negative infinity of x to the nth power, it equals infinity. Same reasons apply. If I plug in negative infinity and raising it to an even power, it's going to become positive. So this is 2 times infinity, which is just infinity. So that's why that works out the way it does. For odd powers of n, if I have the limit as x to the nth power and I'm plugging in infinity, then positive infinity will yield a positive infinity result. If I plug in negative infinity, remember it's an odd power, so I'm going to get a negative infinity out. And here's 2 examples. Once again, you know, the negative one, 3 times negative infinity to the 5th power. I have negative to the 5th power, it stays negative, so 3 times negative infinity is just negative infinity. Okay? So that's what those rules are telling you. So now let's check out the polynomial functions. This is example number 6. And the algebraic technique is to use basic limits at infinity, factor out the highest power of x, and try the limit again if you get an indeterminate form of infinity minus infinity. So infinity minus infinity is not okay. This is an indeterminate form. So if you get that, then you have to factor out a power of x. So let's look at a. So if I look at this, I'm just going to try sticking in infinity first and see what happens. I get 5 times infinity cubed plus infinity squared minus 4, right? So I get infinity cubed times 5 is just infinity. Infinity squared is infinity. And then minus 4, this is okay because this is infinity. See how I have a plus in between? The 2, that's okay. So let's look at b. If we look at this and plug it in, we get 2 times infinity to the 4th minus infinity to the cubed root, or sorry, infinity cubed, I should say, plus 2 times infinity squared plus 1. Okay? So in infinity to the 4th power is infinity times 2 is just infinity. Infinity cubed is infinity. And then we have plus infinity minus 1. Right here, this is a problem because we have infinity minus infinity. That is not okay. It's an indeterminate form. So therefore, now we have to use an algebraic technique. So it says to us, and I'm going to erase this, it said to factor out the highest power of x and try it again. All right, so the highest power of x in this is x to the 4th. So if I factor out x to the 4th, remember when you factor out, you're dividing each one by x to the 4th. Okay, so I get 2 minus x cubed divided by x to the 4th is x to the negative 1 plus 2x squared divided by x to the 4th is 2 over x squared plus 1 over x to the 4th is going to be negative x to the 4th. So let's change this to negative plus negative x to the negative 4th. Okay? All right. So that's what we got. Now we're going to apply the rules. So if I rewrite this, I get x to the 4th times 2 minus 1 over x plus 2 over x squared plus 1 over x to the 4th, right? Remember, 1 over x goes to 0 when I plug in infinity. 2 over x squared goes to 0. And then 1 over x to the 4th goes to 0. So basically what I have left is 2. So I have x to the 4th times 2. Now plugging in infinity, I get infinity to the 4th times 2. And that results in just infinity. So if you get infinity minus infinity, factor out the largest power of x, and then do the problem. Okay, so we did that one. The next page is on exponential functions and logarithmic functions. So I'll probably get through example number 7 here, and then I will make a video for the last 2 pages. Okay, so this is going to be part 2 and part 3. Exponential functions, logarithmic functions. The basic exponential limit as x is approaching infinity of e to the x equals infinity. And if we plug in x approaching negative infinity, it's going to go to 0. Because if you remember the graph of e to the x, it looks like this. So if I'm going from left to right, we see it's growing. And if you go from right to left, we see that it goes to 0. So that's why that's true. And then the basic natural log limits, if I'm taking a limit as x is approaching 0 from the right, the natural limit of x is going to be negative infinity. And the limit as x is approaching positive infinity of ln of x equals infinity. Okay, so if I look at this, if I'm going, from right to left, it's growing, so it's going towards infinity. However, I can't do negative infinity just because it doesn't exist over there, right? There's no negative x's. So what it's saying, hey, if I'm approaching x is approaching 0 from the right, what's going on? Well, if I'm approaching from the right, I'm seeing that this is going to negative infinity. Okay? All right, so let's look at example number 7, find the limit. It says limit as x is approaching negative infinity. of 2 minus 5x squared. The limit as x is approaching negative infinity of 2 minus 5 e to the x. Okay, so if we plug this in, I get 2 minus 5 times e to the negative infinity. Now we know e to the negative infinity goes to 0, so we get 2 minus 5 times 0, so this equals just 2. Okay? And in B, I have 3 e to the positive infinity over e to the positive infinity minus 4. And we know that e to the infinity, when we're talking about limits, it approaches infinity. So I get infinity over infinity. So that's a problem. And the reason why is because it's an indeterminate form, so this is no good. So what do we do with it? So what you can do is you can do the same technique we used before, dividing each one by the power in the denominator. So I can do 3 e to the infinity over e to the infinity over e to the infinity over e to the infinity minus 4 over e to the infinity. Okay, and what happens this time is these cancel out, so I get a 3 in the numerator. E to the infinity over e to the infinity is 1, and 4 over e to the infinity, remember that this is going to be 4 over infinity, so that approaches 0. So I got 3 over 1, which is just 3. Okay? All right, so I'm going to actually do C on the next video because we'll pick up right here. And I'm going to stop this because it's getting long. So I'm going to stop the recording, and you have one more video recording to do for this section.